I want you to imagine, just for a second, that a staggering 40% of the critical components running your company right now are effectively a total mystery.
Yeah, a massive blind spot.
Exactly. Over 40% of enterprise legacy code components operate with, well, little to no reliable documentation.
Which is just wild to think about.
It really is. So welcome to our deep dive. Today we are unpacking a really fascinating stack of recent software engineering white papers, enterprise architecture reports, and case studies.
Lots of deep data in the...
For sure. And we're trying to figure out why this missing documentation is not just some, minor technical annoyance for engineers complaining in the break room.
Right, it's much bigger than that.
Oh, absolutely.
Oh.
We're looking at a massive hidden business vulnerability. And of course, we're going to explore how a new AI-powered approach is stepping in to actually solve it.
Which is the really exciting part.
Definitely. Okay, let's unpack this. Think of operating these legacy enterprise systems like inheriting a massive, sprawling, incredibly expensive mansion.
Okay, I like this.
But somewhere along the way, you completely lost the blueprints.
Oh, man.
Right. Now you want to renovate. You want to add a new room. But you have absolutely no idea which walls are load-bearing and which ones are just drywall.
It's the classic problem of Chesterton's fence, but applied to enterprise architecture.
Chesterton's fence.
Yeah, the principle basically says you should never tear down a fence until you understand why it was built in the first place.
Ah, right. That makes sense.
But in regulated industries like finance, healthcare, or, large-scale manufacturing, these organizations are relying on massive fences that haven't just been built overnight.
They've been there forever.
Exactly. They have evolved over decades. Their process of incredibly sensitive data, enforcing deeply complex business rules, and supporting mission-critical operations every single second of the day.
Wow.
And the reality is, the organization fundamentally relies on systems they do not fully understand.
Which sounds terrifying.
It is. When you don't understand the system, your operational control over that system is incredibly fragile. You don't know why a specific line of code is there, so you are just terrified to touch it.
I have to push back here, though.
Sure.
Because, we all know modern software development leans heavily on agile methodologies, right?
Yeah, of course.
And agile explicitly prioritizes working software over comprehensive documentation. Like, getting features out the door is the mandate.
It's all about speed.
Right. But still, letting 40% of your critical infrastructure go completely undocumented, that seems reckless, even for the most aggressive sprint cycles.
It really does sound reckless on paper.
So wait, shouldn't developers just, write it down as they go? Why do they stop using the documentation altogether? What's the systemic failure here?
What's fascinating here is that the systemic failure isn't laziness. It's actually the sheer velocity of the modern business environment colliding with the reality of legacy architecture.
Okay, how so?
Well, think about how these massive systems are actually built in the real world. They are almost never built in a single, clean, highly documented phase.
Right, it's always piecemeal.
Exactly. Over 10, 20, or 30 years, they are constantly being extended, patched, and reworked.
Like adding rooms to that mansion.
Yes, exactly. A new international financial regulation comes out, so a team has to quickly patch the transaction code. A new digital platform emerges, so they bolt on a custom integration.
Okay, I see.
Each of these iterations introduces a whole new layer of complex logic, and because the business is demanding immediate delivery, no one pauses to revisit or update the master documentation.
So the documentation just shatters, like it can't keep up with the code base, so it splinters into 1,000 different places?
It fragments entirely. You end up with a situation where some of the system's logic exists in outdated text files sitting on an archived server.
Yikes.
Yeah. Some of it lives in an internal enterprise wiki that hasn't been updated since, 2018. And some of it is literally embedded in cryptic code comments written by a developer who left the company 5 years ago.
That is a nightmare.
And the most critical knowledge? That often lives strictly in the minds of a few veteran developers who have been there since the beginning.
So it's just tribal knowledge at that point.
Completely. The documentation doesn't just become incomplete, it becomes actively misleading.
Oh, because the code moved on, but the docs didn't.
Exactly. And the moment developers realize the internal wiki is lying to them, that it doesn't reflect the current production code, trust in the documentation completely erodes.
I just stop looking at it entirely.
Yep. Teams revert to trial and error, institutional memory, and informal word of mouth just to keep the lights on.
Which means They are essentially walking through that mansion in the dark, tapping on walls and hoping for the best.
That's a great way to put it.
And that operational blindness inherently bleeds into the balance sheet. There's a recurring theme across these white papers we looked at.
Oh, definitely.
Yeah, when you lack system understanding, every single deployment is a roll of the dice. The sources paint a pretty grim picture of how this technical gap escalates into a multi-layered business crisis.
It really cascades across the entire organization. I mean, one of the sources explicitly says, when no one fully understands a system, every change becomes a risk.
Right, operational risk.
Exactly. Let's say the marketing team wants a simple update to a customer portal.
Seems easy enough.
Right. So the development team goes in, makes what looks like a minor modification, but because they have no visibility into the deep undocumented dependencies, that small change triggers a massive downstream failure.
Oh, man. So suddenly the payment gateway goes offline.
Exactly. And troubleshooting goes from being a structured, logical process to a frantic, reactive scramble.
Do they have to figure out what the system's even doing before they can figure out why it broke?
Precisely. Which brings us to the financial risk.
Right, because while they are scrambling, they aren't coding new features. They're spending weeks doing digital archaeology.
Digital archaeology is the perfect term for it.
The reports actually call this rediscovery, and it sounds incredibly expensive.
It is a massive financial drain. Instead of delivering value, highly paid engineers are spending thousands of hours annually just staring at existing code, trying to reverse engineer what it does.
That's just throwing money away.
It is. Hidden complexity leads directly to budget overruns. But there's a third risk here, too, which is talent and knowledge risk.
Right, the human element of this archaeology. Who are the people actually doing the digging?
Usually the few veterans who still remember how the foundation was poured.
Yeah, in many organizations, critical systems are understood by a handful of people, or sometimes literally just one person.
Which is terrifying for management.
It's like a high-stakes game of Jenga. You've got this towering infrastructure of enterprise operations, and it's all resting on the institutional knowledge of, say, Dave in engineering.
Good old Dave.
Right. Dave knows the deeply nested COBOL banking rules. But if Dave pulls his block out and retires, or even just takes a 2-week vacation, the whole tower of institutional knowledge collapses.
It creates a structural fragility that is completely unsustainable. You lose operational continuity the second Dave walks out the door.
Wow.
And think about onboarding new engineers into that environment.
Oh, I can't even imagine.
The learning curve is practically a vertical cliff because there is no trusted reference material. New hires just have to constantly interrupt Dave to ask how things work, which destroys Dave's productivity.
And I imagine this informal word-of-mouth knowledge transfer is an absolute nightmare for compliance.
Oh, it's the worst case scenario, which is our fourth, risk compliance and audit exposure.
Because regulators don't want to hear what Dave thinks the code does. They want actual proof.
Precisely. For regulated enterprises, compliance and audit risks are severe. You have to prove to regulatory bodies exactly how sensitive data is processed, how privacy rules are enforced.
Right, and how financial transactions are routed.
Yes. And without comprehensive documentation, you are facing agonizingly long, highly manual audit cycles. Teams are put under immense pressure to manually trace logic and reconstruct behaviors for the auditors.
Which just invites more mistakes.
Huge non-compliance exposure.
So an auditor asks, how does a user's health data move from this portal to the back-end database? And the company basically has to respond, give our engineering team a month to read our own legacy code, and we'll get back to you.
Pretty much. And that delay is exactly why these architecture reports argue that documentation is no longer just a passive artifact you store in a drawer and forget about.
Right, it's active.
It is a fundamental mechanism of operational control. If you cannot see the logic, you cannot control the system.
But I mean, if the business risks are this severe, if it is actively causing operational outages, draining millions in rediscovery costs, creating dangerous talent bottlenecks, and risking regulatory fines, why do companies just live with it?
It's a great question.
Like, if the 40% gap is a known glaring problem, why hasn't the enterprise fixed it?
Because they have been trying to solve a scale problem with a completely antiquated tool.
Manual documentation.
Exactly. Manual documentation simply fails when applied to massive legacy systems.
Why exactly? Just the time it takes.
Time is a big one. Fast-moving environments prioritize delivery, so documentation gets postponed or skipped. But even when teams do try to write things down, you hit the paradox of decay.
The paradox of decay.
Yeah. The code base evolves daily, but the isolated Word documents and wiki pages don't. So a paradox emerges where documentation exists, but it's completely useless.
And it seems like there's a massive inconsistency issue too, like a language barrier.
Absolutely.
Because even if the wiki is perfectly updated, it's usually written by an engineer for another engineer. It assumes a deep foundational technical context.
That accessibility issue is a massive bottleneck. A deep technical breakdown of API endpoints is completely useless to a compliance officer.
Right, or an internal auditor.
Or an executive who urgently needs to understand the business logic but doesn't read code. Different teams use totally different, incompatible formats.
Yeah, one group might draw process flows on a whiteboard and snap a photo. Another group just leaves, sarcastic comments in the source code.
Exactly. There is no unified, cohesive picture of the enterprise.
Here's where it gets really interesting, though. The definitive takeaway from the sources is that manual documentation doesn't scale. And in legacy systems, scale is exactly what's needed.
It is the only thing that matters.
So you can't just throw an army of human typists at a 30-year-old code base and expect them to map it out. It's physically impossible.
Not going to happen.
Which means the entire enterprise mindset has to shift. We have to stop viewing documentation as a static file that gets updated once a quarter and start treating it as living infrastructure.
Living documentation.
It's like, okay, traditional documentation is like keeping a printed roadmap from 2005 in your glove box.
Right.
Sure, it was highly accurate the day it was printed. But today, half those roads are one-ways, there's a new highway, and you're going to drive straight into a lake if you actually trust it.
I love that analogy.
Thanks. A living infrastructure, on the other hand, is like a live GPS on your phone. It updates with traffic, road closures, and new routes in real time.
The GPS analogy highlights exactly what we mean by continuous synchronization.
Okay.
A living documentation system must be automatically generated, continuously updated in real time without human intervention, and accessible across different business roles.
It has to evolve at the exact same pace as the code base itself.
If we connect this to the bigger picture, think about how modern companies allocate their IT budgets.
Oh, sure. Millions.
Right. They invest massively in cybersecurity and server redundancy and cloud infrastructure. They build incredibly sophisticated fortresses around their systems.
But they forget what's inside the fortress.
Exactly. They completely neglect the knowledge of the system itself. In modern organizations, knowledge is infrastructure, and undocumented systems represent a failure of that infrastructure.
But, the GPS analogy is great for understanding the end goal, but a map app relies on satellites to get a top-down view of the roads.
Right.
How do you actually get a satellite view of a 30-year-old, fragmented, deeply nested code base? Executing this paradigm shift on tangled enterprise code seems like a monumental task.
It is monumental. But this is where our sources introduce CodeAura.
Ah, the AI platform.
Yes. CodeAura is designed specifically to step into this void and operationalize system knowledge. It represents a shift from relying on human memory to leveraging machine scale.
Okay, break that down for me. How does it work?
Well, first, it completely eliminates the need for manual documentation. It generates comprehensive coverage directly from the codebase itself.
Autonomously.
Entirely autonomously. It maps the system at the individual file level, module level, and the macro system level. You aren't asking veteran engineers to stay late and type up what they did. The AI constantly reads the system and documents it.
And because it synchronizes continuously, as the code evolves, the documentation evolves instantly.
Exactly. It becomes a persistent, highly accurate source of truth.
But this is where I really have to play the skeptic for a second.
Go for it.
Because it is one thing for an AI tool to map out basic modern code structure. We've seen tools that can summarize Python scripts.
Sure, that's pretty common now.
But can an AI really unravel decades of tangled, patched together COBOL or legacy Java?
It's a fair question.
Like, how does it actually make sense of complex business logic that has been buried since the 1990s and then translate that for a compliance officer who doesn't know how to code?
That is the defining technical challenge, and it highlights the difference between basic text summarization and actual logic extraction.
Okay, logic extraction.
Right. CodeAura isn't just reading the text of the code and summarizing it. It is actually tracing the execution paths.
Oh, wow.
Yeah, it maps how variables mutate across thousands of lines of legacy syntax. It follows the data as it moves through complex logic gates and reverse engineers the underlying business rules.
So it's essentially reverse engineering the thought process of the original developer.
Exactly. It is mapping the functional reality of the system. It pulls that deep hidden logic out and translates it into structured, human-readable formats,
Like what?
like pseudocode, visual node graphs, and summarized logic workflows.
That's incredible.
It really is. It bridges the massive gap between the technical implementation and the business understanding.
So yes, a compliance officer could pull up a visual workflow diagram generated by the AI and understand exactly how a financial transaction is processed,
Step by step, rule by rule.
without needing to decipher a single line of legacy code.
Exactly.
That fundamentally democratizes the knowledge. It takes it out of the engineering silo, out of Dave's head, and gives it to the entire business.
And it has an AI-powered queryable interface, so non-technical stakeholders can actually interact with the system's architecture.
The query capability sounds huge.
It transforms how the workforce operates. Users don't have to go digging through files or tracking down veteran engineers.
So a business analyst could just ask the AI interface, like, what downstream dependencies exist for this compliance module?
Yep. And they get a contextual, accurate answer instantly based on the live code.
That is wild.
It transitions the organization from a state of structural fragility and reactive troubleshooting to a state of proactive operational control.
Proactive control. I like that.
And this points to a crucial operational philosophy we see in the sources. Modernization must begin with understanding your existing systems before you even attempt to rewrite or migrate them.
Right, going back to Chesterton's fence. You don't tear it down until you know why it's there.
Exactly.
You have to know what the load-bearing walls are before you start swinging the sledgehammer to move to the cloud.
Absolutely.
So what does this all mean? Let's bring all of this together. The ultimate takeaway from these engineering reports and case studies is incredibly clear.
It really is.
If your organization cannot clearly, accurately, and instantly explain how its own systems work, it is operating at a massive hidden risk.
That is the bottom line.
Modernization isn't just about buying new tools or migrating legacy servers. It's about gaining the absolute visibility you need to reduce risk and move faster without breaking things.
This raises an important question for leadership, really, because overcoming this knowledge gap is where true competitive advantage begins in the modern enterprise.
For sure.
You stop reacting to the uncertainty of your own legacy and you start operating with actual certainty.
And I want to leave you with a final thought to mull over, something that really builds on this concept of an AI mapping out decades of forgotten history.
Yeah, this is interesting.
If an AI like Codora is constantly tracing execution paths and translating 20 or 30 years of patched, tangled legacy systems, what happens when it starts exposing ancient silent bugs?
Oh, man.
Or, massive compounding inefficiencies that human developers completely missed 2 decades ago?
It's bound to happen.
Right. Our enterprise is about to discover that their foundational systems have been hiding dark secrets this whole time. Because once you finally find the blueprints of that old mansion, you might just realize the foundation was built on sand.
Wow.
Thanks for joining us on this deep dive. We'll catch you next time.